The following program is a special presentation of the Big Ten Network, produced in association with the University of Wisconsin.
AIDS has been responsible for the death of 25 million people since 1981. Today, 33 million people are living with either HIV or AIDS around the world. There have been research breakthroughs and most recently news of a possible vaccine. What have we learned about preventing and curing the disease? In what direction is research heading? We'll talk about HIV and AIDS next during Office Hours. Hi, I'm Ken Goldstein from the Department of Political Science at University of Wisconsin. For more than 20 years, researchers have worked feverishly to find a cure for HIV/AIDS. Today, 2/3 of infected people live in Africa, but America is not home free. An estimated 1.2 million people are living with HIV and AIDS in our country, and more than 500,000 people have died of the virus since the beginning of the epidemic. Here to discuss current available treatments, the breakthrough new vaccine, and how the virus affects America in general, and college campuses in particular, are two experts from the University of Wisconsin, Marge Sutinen and Dave O'Connor. Marge is a clinical instructor at the University of Wisconsin Medical School and director of the Midwest AIDS Training and Education Center. She works to coordinate educational opportunities for clinical healthcare providers who work in the treatment of AIDS. Dave is a professor in the Department of Pathology and Laboratory Medicine. He researches HIV disease pathogenesis, and his lab is working on developing a vaccine for HIV. Marge, David, welcome to Office Hours.
Good to be here.
So we're gonna talk about a wide range of things today, but I think it would be worthwhile for our viewers to do HIV or AIDS 101 and go over some of the basics.
Okay.
And remind, how does one become HIV positive? How does one get the virus?
Well, it's interesting, since 1985 we've been talking about HIV infection, and the way that's transmitted and prevented has not changed. You can transmit it by unprotected sex with an infected person, sharing a needle or sharp object with an infected person, from mother to child, although that's drastically changed from us. And before 1985, you could also get it from a blood transfusion. So here we are in this third decade, and it still is the same way that HIV is still being transmitted the same way that it was when we first discovered it.
Well, let me follow up on something there quickly, that it's not the case now that people were getting HIV from the blood supply, because there were stories in the 80s, early 90s of that happening.
Correct.
But that's not an issue anymore?
Early on, no one knew that HIV could be transferred through blood. And then in 1985, a test was designed to be able to screen the blood supply. And today, in America, there's very few, if any, transmissions of HIV through blood transfusions. If it happens, it's because somebody human made an error, but not because of the testing.
Okay. David, take me through the basic science of what happens when one is infected with the HIV virus.
Sure. So what HIV does is it attacks your immune system. And when you're infected, your immune system within the first few weeks starts to try to repel the virus, but it doesn't do a particularly effective job of doing that. And then the immune system and the virus enter into a long period of coexistence where the virus continues to replicate, and in so doing destroys the immune cells that it can infect. The immune system tries to fight off the virus but isn't 100% effective, and eventually the virus tends to get the upper hand unless someone is put on treatment. And when that happens, the immune system can no longer fight off other diseases, and so people develop these opportunistic infections that are characteristic of AIDS. And those infections are ones that would generally not be severe in people with healthy, uncompromised immune systems.
So in reading about HIV and AIDS in terms of these stages, so I read that sometimes when someone's initially infected, they almost have these like flu-like symptoms. So that would be fighting it off. Then it goes not dormant, but there's no outward signs. Then it begins to attack the immune system, and then at some point, HIV becomes AIDS. What's that line, and what's the significance of that line?
Well, I think the line is fuzzy, Marge. You might.
It is because what happens is that your white blood cells fight off, or your immune system's trying to fight off the infection, and the infection is also gobbling up those white blood cells, and so there's this race going on that Dave talked about. When you get to a certain level, when your a CD4 count is at a certain level, then you are clinically diagnosed as having AIDS. So you could be clinically diagnosed as having AIDS with a CD4 count. If I were to test you right now and you're not HIV infected, you would have between 1,200 and 1,000 T4 helper cells per microliter of blood. Well, when you become infected and they begin to drop to a level of 500, you could be diagnosed with AIDS. Or if they drop to a level of 200 and you have an opportunistic infection, you could be diagnosed as having AIDS. What's ironic is that we can now suppress the viral load system so that, with medication, so that you are technically only HIV infected, but we haven't gone back to that definition that once you are diagnosed with AIDS, you always have it, even if your viral load is undetectable. And that confuses people because they say, wait a minute, my viral load is, I'm healthy. But we haven't changed that definition.
So is that an important distinction then? Because it seems like you're HIV infected and it's attacking your immune systems, or your immune system's having difficulty fighting off any other sort of disease. Mm-hmm. And then at some point we say you have AIDS,
right.
But the difference between, can you say, late stage HIV
sure.
and early stage AIDS is almost a distinction without a difference.
Right. Psychologically, though, it's not. If you tell me I'm HIV infected, or if you tell me I have AIDS, I'm going to have a different reaction to it. If you have my insurance, my job, many things are going to come into play for me. If I have HIV, it's more like a chronic illness. If I have AIDS, even though we're in the third decade, I hear death. Even though that isn't the case anymore, I hear death. And so what we try to do is to make sure that people understand that they are HIV infected and they have not been diagnosed with AIDS yet.
So thanks for joining us on Office Hours. When we come back, we're going to discuss some of the strategies that are used to stop HIV from turning into full-blown AIDS. Thanks for joining us.
This program is a production of the University of Wisconsin-Madison. If you have comments about this broadcast, please email them to programming@uc.wisc.edu.
For more than 100 years, the University of Wisconsin has been inspired by the Wisconsin idea,
which says the good work of the university extends to the boundaries of the state and beyond.
So the UW works hard to help build Wisconsin's economy.
Educate people of all ages.
Advance health and medicine.
And enhance the quality of life for all of us.
Hit it!
The University of Wisconsin-Madison. Forward thinking.
Welcome back to Office Hours. We're talking about HIV/AIDS and possible new treatments. Dave, let me turn to you now. And we talked about the progression of the virus into full-blown AIDS. What's the current treatment, and what's the strategy or the rationale behind the current treatment?
Sure, the strategy is very straightforward. Throughout an infection, it really is a race between the virus and your immune system. And without treatment, the virus eventually wins. It destroys the immune system so that it can no longer fight off other diseases. If you can treat the virus and prevent the virus from replicating in the body, the immune system can start to gain the upper hand. So the goal of treatment is to drive the amount of virus in the blood down to levels that are undetectable. So basically, you don't have HIV virus actively replicating in the body. It's still hiding, so it's still there, but it's not replicating actively. And that lets the immune system recover and regain some of its ability to fight off other diseases.
So you hear the term, the AIDS cocktail. Mm-hmm. What does that mean?
Well, the cocktail is simply the idea of combining multiple drugs together into a cocktail, like you'd mix a drink. The reason you want to do that is because if you treat HIV with any one drug, the virus is rapidly going to develop resistance to the drug. If you treat someone with 2, 3, or 4 drugs, then it's much more difficult for the virus to develop resistance to all those drugs simultaneously. And that is really the advance that allowed us to drive this amount of viral replication in the blood down to undetectable levels and keep it there for a long period of time.
So Ken, when it infects the cell, and I'm stepping on Dave's toes here just a little bit to explain, the medicine can be given so that it can stop the when it enters the cell, when it's in the cell, or when it's exiting in the cell. And that's why you want all that medication, because they can do a combination of things with that cell. Not just, we used to just give one and thinking, well, that's going to kill the virus, but it doesn't, you know, so that's part of it. About 27, 30 different cocktails that you could take.
So what doctors are essentially doing is desperately trying to to protect the immune system and to kill as much HIV as they can, so that HIV doesn't then kill your immune system.
Right.
That's right.
One of the problems that we have, though, is that it mutates. So it not only makes itself, as Dave tells us, that we become the virus factory, and we make lots of virus. But the virus is smart enough to make itself over, but it's so dumb when it makes itself over, it makes a different copy. So it's mutating, so it's constantly changing, and the immune system is trying to figure out, well, what am I fighting now, because it looks different.
So I think sometimes the popular impression is that the AIDS cocktail is a cure. It's not a cure, it's a continuing delaying action.
So now we talk about HIV as a chronic illness because of the medication, as opposed to a death sentence. But it certainly doesn't kill the virus. As Davis says, you can't get rid of it. Once it's in your body, you're infected forever.
And not only that, but many of the drugs have very significant side effects and toxicities that are really unpleasant. And when people talk about it as a chronic disease, that leaves the impression that it's easily treatable and easily kept under control, and that's not the case at all. If you're taking these drugs, you have to go in for regular physicals. You have to be monitored to make sure that the virus isn't becoming resistant. You have to have your other organ functions measured to make sure that the drugs aren't causing your liver or your kidneys to shut down, that you're not developing high cholesterol, because many of the drugs have very significant side effects, and all of them, to one degree or another, do.
Let's talk about Magic Johnson for a second, because for someone of my generation, that was the dominant case. Right. And thankfully, thank God, Magic Johnson is still alive. Right. And I think if you would have asked that question however many years ago, no one would have predicted that. The flip side is that I think there's that perception that
he got
takes the cocktail, either he got something special, or he takes the drugs, got cured, no side effects.
Right. Well, first of all, I think Magic Johnson, I think because I wasn't there with him, but he got tested early, not because he thought he was HIV infected, but because he had to pass a physical. So early detection always helps the person, because the sooner they know they're HIV infected and they can begin to take the medication, the sooner that you can begin that fighting that goes on between the cell and the virus. So that's, I think that's what...
So it's really as simple as that. So people might be scared about getting the test, not wanting to know. Bottom line is...
Or get tested early.
If you know there's something that can be done, then you can get these antivirals, they can start fighting.
Well, the earlier you start the fight, the earlier you knock down the virus, the better off you're going to be. And that's really the lesson that's been coming out of the studies for the last few years. And I think Marge's absolutely right, that he had the advantage of being caught early. And then there's also the difference between people. Some people, for reasons that we're aggressively trying to understand in the lab, simply are better at controlling HIV than others. He may have a rare genetic attribute that makes him more resistant to HIV than average people. There's about 1 to 2% of all people with HIV fall into this category of so-called elite controllers, who, despite not having the need for therapy, manage to effectively control the virus for long periods of time. We've had some elite controllers who have been followed since the early 1980s. They haven't lost their CD4 cells. Their immune systems seem to be winning. And it's an active area of investigation to figure out why their immune systems win when in almost everyone else's, the virus wins.
He might have also
we're going to have to run to break now, but we'll get right back into it, and please stay with us on Office Hours. Recently in the news, there was news from Thailand of a successful test of a vaccine. Can you take us through the basic details of the findings of that?
Yeah, so this was a vaccine trial that was sponsored by our government in collaboration with the Thai government. And they basically asked the question of, if you'd combine two different types of vaccines to tickle different parts of the immune system, will you get a better effect than if you use either one of those by itself? They put together two products that by themselves hadn't been very effective, and so there wasn't a lot of optimism in the field when the vaccine trial was initiated several years ago. The results suggested that the people who received the vaccine were about 30% less likely to become infected than the people who received the placebo, though the numbers of infected people in both groups were quite small, and the actual data breakdown of those groups is still...
So talk to me about that. So the headline says 30%. Because I'm a geek and I like looking at the research design, I went and looked at it, and it was, they gave this vaccine to 8,000 people, gave a placebo to 8,000 people, and 79 or 80 in the placebo group became infected with HIV, and then 49, 50, 51.
Well, this is the challenge of doing a vaccine trial, is that to do a trial ethically, you have to give the absolute best education and prevention message to all the trial participants that's available. And so all 16,000 people in the trial were taught how not to get HIV, how to wear condoms properly, and they were given condoms. So you try to keep everyone in the trial from becoming infected. Some people become infected anyway. And that's the only thing that you can really measure in a trial like this. So the numbers were small, but partly because the trial was a success and kept a lot of people who otherwise might have been infected uninfected through prevention and education. It does make it hard to analyze the data, though.
So I'm trying to think about what way the bias would be. So if you did this counseling, intense counseling of both groups, and then people obviously then still engaged in unsafe sexual behavior or probably drug use, and some segments still got it, does that make us think that vaccine might even be more powerful? Because those people were probably doing they had all this information, and they still did the risky behavior.
It's just really impossible to say right now. The only thing that we can say is that the last large-scale trial that was run actually had more people infected in the vaccine arm than in the placebo arm. And that was a crushing disappointment because a lot of people thought that was going to be a great vaccine. This vaccine people had much lower hopes for, and yet it appears to have worked well. We can only do so many of these trials with tens of thousands of volunteers, and we've in fact only done 2 or 3. So the fact that we're seeing an effect, even if science can't understand it, is going to definitely merit further investigation.
So unambiguously good news to get even a modest positive effect. In your work with college students, do you worry, though, that they then read in the newspaper that there was this 30% effective rate of a vaccine, and does that hinder some of the sorts of messages you're trying to get out?
Oh, that's interesting, Ken. I asked the students actually last week how they would feel about that, and they said, oh, this is really great news, except that maybe I would have more unprotected sex if I knew that. But then I said, how many of you would line up and get tested with the vaccine? And they're like, no, I don't want to be the person to try. So, we get mixed messages from them, but definitely, I think the vaccine is a good hope for us. Certainly, that many of us who've been working in this field for such a long time, we need some good news. But on the other hand, the vaccine is not the cure-all. HIV prevention is.
And when we come back in our last segment, we're going to talk about some of those prevention strategies. Hope you'll stay with us on Office Hours.
For more than 100 years, the University of Wisconsin has been inspired by the Wisconsin idea,
which says the good work of the university extends to the boundaries of the state and beyond.
So the UW works hard to help build Wisconsin's economy.
Educate people of all ages.
Advance health and medicine.
And enhance the quality of life for all of us.
Hit it!
The University of Wisconsin-Madison. Forward thinking.
This program is a production of the University of Wisconsin-Madison. If you have comments about this broadcast, please email them to programming@uc.wisc.edu.
Welcome back to Office Hours, where we're discussing AIDS and HIV. So David, tell me a little bit about what the most current research is on prevention. We talked about lots of research on treatment. We talked about the science of how one gets infected, but there's also been some relatively new research that empirically looks at what sorts of prevention strategies work best.
Sure, and it's absolutely thrilling to be part of the HIV prevention science right now. There's still nearly 3 million people getting infected with HIV each year, and only about 1 million worldwide, of which only about 1 million people are being newly added to the rolls of people with treatment each year. So there's a lot more people becoming infected than we can treat. So we need to prevent infections. And in the last few years, we not only have this new and encouraging news on vaccines to prevent infection, But we've also learned that if a man is circumcised, he reduces his risk of acquiring HIV by 50% or more. So there's now active campaigns to circumcise men, particularly in areas with high HIV rates. And we've also had a resurgence in research into microbicides, which are creams or gels that a woman could apply to prevent HIV infection. And we're awaiting results from a clinical trial that looks at using the HIV drug cocktail drugs to prevent HIV infection in people who are at high risk of becoming infected. So 5 years ago, we didn't have anything scientifically that we could bring to bear to prevent infections. Now, thanks to the recent research, we finally have something we can work on.
Marge, you've been involved in AIDS education and AIDS prevention for a number of years, and on college campuses. What's changed in that time period of what you say to college students, what college students know when they get to campus?
Well, first of all, it's great that Dave points out that the contributions that take place in the way that he's just explained them to us. But the bottom line is that abstinence, not exchanging infected fluids, is a sure way of not becoming infected. Maybe not a practical way, but it is a way that you certainly are not going to become infected. Using barriers properly. And you're asking me what the students on campus do. It's amazing to me that students don't know how to use condoms properly, or they don't know how to bring them up, or they don't know when to bring them up, or they say, I'm too drunk, I forgot to bring them up. And I mean, these are things I hear weekly when we're teaching the class. And so students are very aware now that in the class, especially, that they need to take more action, and they can prevent by using barriers. So that hasn't changed since day one either.
So obviously abstinence is a foolproof strategy,
Sure.
but what's the evidence on abstinence education? What's the net impact
Thank
of
you for
that?
asking that. That's a tough one. It's certainly we know that it works if it works, but we also know that abstinence doesn't work for many people. And to be able to balance, this is how you can prevent it 100%, but if you're not abstinent, this is what you can do. And we don't often mix the two, it's either or. And so people, again, the students say to me, all I was taught was don't have sex. And it doesn't teach me the skills. It's like, when you're riding your bike, are you going to learn the skills and how to make sure that you cross the street right and put the helmet on and all those things? And so it's important that we balance the information.
Great. David, Marge, thanks so much for joining us today on Office Hours. I know David's going to be going off to Paris in a couple weeks to actually hear firsthand these results from this Thailand study, and hopefully you'll come back on Office Hours and tell us what you learned and a little bit more about your research. And I hope everyone else out there joins us on Office Hours next time. Thanks for stopping by.
The preceding program was produced by the University of Wisconsin in association with the Big Ten Network.